Okay, let's wait a little bit till all our participants join us. Just a few moments. Welcome to our webinar. Till everyone is joining, I would like to check the video and audio, as last time we had some issues with broadcasting. Could you please write plus in the chat if you can see us in the presentation and you can hear me well? Okay, I can see your pluses. And also our technical team confirms that everything is set properly. So good. Just a few moments till everyone join us. We expect about 160 people here today. That's great. And we have audience from different countries. So far I can see people from the United States, Canada, Israel, different countries of Europe, and Ukraine, of course. Yeah. So, and among our participants today, there are different companies. I can see small startups as well as mammoth companies that have been on the market for many years. It's truly inspiring to have such a diverse group gathered here today, united by AI and cybersecurity. And this is my favorite combination of technologies, you know. Okay. I think we can officially start. For those who are running behind, there will be a recording. So, good day, everyone. I'm thrilled to welcome participants from all over the world to our webinar on the power of AI in behavior analysis for cybersecurity. You know, AI is becoming more and more popular every day, and there are so many discussions about its role in cybersecurity. Is it really beneficial to use AI in cybersec solutions? Or it's just simply overhyped? There is so much confusion about this question. And today, we will shed light on it. In our webinar, we will take a closer look at the behavior analysis. We'll compare AI approaches to the traditional methods. We'll dive into AI methodologies, see real practical cases, and address the challenges in implementing AI. I'm Olha Kalamoitz, I&D Delivery Manager at Apriorit, and I work directly with AI solutions. At Apriorit, we have been doing cybersecurity outsourced development for almost 22 years. And today, our main speaker is Vadim Nevedomy. He has a decade of experience with cybersecurity projects, and he successfully combines his huge expertise in low-level development and his passion for AI and machine learning. And before we start, I would like to welcome you to engage actively in our webinar and write your thoughts, your questions in our chat. And we will address them at once or later during our Q&A session. So, Vadim, you're welcome.
Thank you. Hello, everyone. Today we are going to talk about behavioral analysis in cybersecurity. So let's start with definition. Behavioral analysis is like being a detective for computer behaviors. It's about studying how data moves and how people use computers to find anything unusual. Why do we do this? Imagine a thief trying to hide in a crowd in the same way dangers on the internet try to hide in normal activities. Our usual defenses like antiviruses and firewalls are good at stopping dangers they know, but they might not catch a thief who's dressed up differently or sneaks in another way. That's where behavioral analysis helps. It looks for tiny clues that something's wrong, like a change in how data moves or activities happening at odd times. By paying attention to these clues, we can spot new threats and protect ourselves better. Uh, okay, in a nutshell, behavioral analysis helps us to examine the clues left by digital activities, finding hidden dangers. In today's world, where online dangers are very sneaky, user and entity behavior analytics is our best tool. UEBA watches how users behave normally, then if something odd happens, it knows. This is very useful for stopping dangers before they cause problems. UEBA doesn't just watch over users, it learns how they usually act. When something unusual happens, it alerts us. This helps us find threats before they cause harm.
So to summarize, behavior analysis helps us to prevent attacks or at least minimize them when cyber criminals are already inside the system, right?
Yeah, correct.
Okay. And as I know, behavior analysis isn't a new thing. Many cybersecurity solutions and some of our customers already have it, but usually it's based on statistical techniques. And they work pretty good. So, what is the point to integrating AI?
We are just going to talk about that. So, uh, as cyber threats get smarter, we need to update how we find and respond to them. We are looking at the difference between old and new ways. So, we have traditional approaches. Think of a castle with fixed walls and guards who only know a few ways to spot enemies. These methods don't change, they follow set rules, making them less useful against new or complex attacks. They often mistake harmless actions for threats because they rely on known dangers, leading to many false alarms. Uh, on the other hand, imagine a castle that learns from every attack. It's not just prepared for all tricks, but also adapts to new ones. AI in cybersecurity is like this learning castle. It keeps getting smarter, finding hidden threats by noticing unusual behavior. This smart approach means fewer mistakes, as it learns what normal looks like, making it much better at finding new dangers. Here's a simple comparison. First of all, adaptability. Traditional security methods are static, sticking to predefined rules that fail to evolve with new cyber threats. In contrast, AI-enhanced approaches are inherently adaptable. The second one is learning. Unlike traditional methods that operate on a fixed set of signatures and rules, AI-driven cybersecurity solutions learn from the data they process. This continuous learning process enables AI to not only recognize known threats, but also to improve its understanding over time. Finding threats. Traditional security measures are limited to identifying threats they have been explicitly programmed to recognize, often missing novel or sophisticated attacks. AI-enhanced systems, however, can detect anomalies in behavioral patterns, allowing them to identify potential threats that have never been seen before. Spotting unknown dangers. Traditional methods are often ineffective against new unknown dangers, as they rely on historical data and known threat patterns. AI, on the other hand, analyzes current behavior in the context of what it has learned, making it adept at spotting even the most subtle signs of unknown dangers. And mistakes. Traditional cybersecurity approaches tend to generate a high number of false positives, mistaken benign activities for threats due to their reliance on predefined rules and signatures. AI-enhanced systems minimize such mistakes by learning what normal behavior looks like for a given network and adjusting the benchmarks over time.
Yeah, I can add it. Uh, from our experience, the main pain of using traditional statistical analysis is a large amount of false positives. And every alert should be processed manually by a human, and that's a huge amount of work, especially for big corporations. But after integrating AI, we can see a significant reduction of false positives because it can learn, adapt, and find complex patterns and correlations. So, yes, using AI in this case is really beneficial.
Okay, thank you. Uh, Now let's explore how AI helps in spotting cyber threats through UEBA, focusing on known popular algorithms. The first one is neural networks. They're great at finding complex patterns in lots of data, helping to spot subtle signs of cyber threats. But they're like a puzzle box, hard to see how they make decisions, which can be a problem for clear explanations. The second one is decision tree. Decision trees are easier to understand. They make decisions by following a path based on data. In cybersecurity, they help quickly decide if something is a threat. However, they can be too simple sometimes, not working well with complicated data. And clustering algorithms. They help when we don't know how to classify data. They group similar behaviors, helping find anything that doesn't fit, which is useful for spotting new threats. The challenge is deciding how many groups to make and understanding the results. By combining these AI methods, UBA becomes much better at finding and stopping cyber threats as they happen.
And Vadim, which methods is the best for behavioral analysis?
Nowadays, I'd recommend using neural networks, but actually, it depends. If you are prototyping something, you are checking some approach, creating a POC. It's better to start with more simple solutions like clustering algorithm and decision trees. They are much easier to train, and usually they're faster to train. So you will get feedback faster.
Oh, okay.
Okay. Let's take a look at some key components of anomaly detection in UBA. The first one is collecting data. This means bringing together information from everywhere, like logs, network data, to see normal and strange behaviors. The second one is profiling behavior. Using machine learning, UBA figures out what's normal for the organization, helping tell apart harmless actions from dangerous ones. Spotting anomalies. It uses smart models to find when actions don't match normal patterns, quickly spotting potential threats. Benefits include finding dangers early, reducing mistakes in identifying threats. But there are some challenges in anomaly detection. Challenges include dealing with the huge amount of data collected, keeping up with new types of threats, and ensuring the system can tell the difference between unusual and but harmless behavior and real risks. Uh, benefits uh, Benefits of UEB anomaly detection is early threat detection, as we discussed, and less rate of false positives. Also, dynamic profiling. It allows us to adapt to changing behaviors quickly. So now we can consider a few case studies and real world examples where UBA really helped organizations to find and help and save and make their data safe and protect their customers. So let's talk a bit about financial sector. In the banking world, a big international bank faced complex fraud problems, where criminals copied customer actions very closely. To fight these threats, the bank used a system called User and Entity Behavior Analytics uh, that use smart computer programs to carefully check transaction patterns and how users act. The important step helped the bank spot and stop fake transactions that could have cost millions of dollars. Thanks to this, the bank greatly reduced money loss and at the same time increased trust from their customers. The successful use of UEBA in this example shows how effective it is in finding and stopping complicated fraud in the banking sector. The next one is healthcare sector. In the healthcare field, a well-known provider faced two big problems: uh, bad actions from people inside the company and attacks from outsiders, both threatening private patient information. To improve their security, the organization started using a UEBA system. The system watches over the users, over who gets into and what happens around secret data, spotting and highlighting unusual behavior that might mean someone is getting in without permission or possess a threat from within. Thanks to this method, they were able to stop several attempts by insiders uh, to do harm and block unauthorized access drives, keeping patient information safe and following strict rules for keeping data secure.
Yeah, these are good examples how AI can help companies to avoid losses and protect sensitive data. And there is a prediction from cybersecurity ventures that the global cybercrime costs will increase and reach $10.5 trillion by 2025. And that means that we should expect more attacks and their complexity will increase because uh, threat actors are using AI against us. So it's a good time to start thinking about enhancing your protection till it's not too late.
Yeah, correct. Because different threats are always evolving, and so that's like a competition, and it has always been like that competition between cybersecurity teams and different kind of hackers.
Yeah, exactly.
Okay, let's take a look at the deep learning based solution for detecting some attacking behavior. The first example is this convolutional neural network based anomaly detection system. Since convolutional neural network is great for image processing, so users' daily behavior is encoded into a multi-channel image. So if you look at these two graphs, these are just the two normal user behavior during a day. If you look at the user one, if you look at this graph on the left, uh, the y-axis here represents the 24 hours of the day, and the x-axis here represents like 60 minutes of an hour. So each cell in this subgraph represents, in each subgraph for HTTP, FTP, represents a certain minute of that day. And the column of that cell represents any of these numerical numbers. In this case, actually, we monitor the data transfer volume from each user. So in this case, actually, the higher the number of the volume or bytes of the data is transferred, the redder cell is. So here, for example, we see that user 1 uses HTTPS protocol quite intensively. Okay, so in this way, we can encode each user's daily behavior across all these different protocols. You can see from these two graphs, these are two normal users' daily behavior. It's very clear both of the users are actually 9 to 5 p.m. or 9 to 6 p.m. users. They come to office, they work. But the difference here is it looks like the user 2 actually likes to have a long time to lunch break. This is what tells us from this graph here. But the user 1 seems to be working harder in the office all the time. We could even try to differentiate, try to break this into more granularity subgraphs. Like say, if we monitor the user, because here we just put all of the encrypted communication under HTTP graph. But these days, there's too many applications going there, like LinkedIn, Facebook, different social networks. If we actually break this down, some of this encrypted communication could go to like LinkedIn subgraph, Facebook subgraph, and so on. So we can divide it further to get a better and more detailed insight of user behavior. So this is about image-based fingerprinting for each user. Now let's look at user behavior and machine behavior, and let's compare them. So you can see from the machine behavior some of regularity here. It's not surprising just because most of machines these days are just configured to do one or small number of this specific work. So you can see these regular patterns here. Some service will be accessed or the data will be backed up at some frequency, but not very high volume here. And with this image encoding, we can just convert each of either user or device like a daily behavior into some graph. And the next thing is to build this image fingerprinting for each user and device, and label them with certain user name, user ID, date, and group information. So it can be done. We collect such information for each user and label it appropriately. So now let's take a look at neural network architecture. We feed all that collected information about each user in our organization and train our convolutional neural network. Here you can see feature extraction part and classification part. So we expect here in the training stage, after we feed all of these daily users' behavior images into the network, and after we finish all of the training, we expect each node from the output layer represent a unique user in the enterprise, in the organization. So that's the reason the way we encode user behavior in images. Also it has to be very discriminative. So if when our neural network is trained on all of the users and all of the images in our organization, it could tell apart and classify users based on image that is passed to it during inference stage. So If we pass a new image to the trained neural network and some node in the output layer will light up. If this node is the same user as the training data, which means that the user's behavior that is passed to the neural network is the same or similar to the user's historical behavior, it's okay. So no anomaly detected on the image, on the new image. But if this user happens to light up a different node in the output stage during the detection, it means that the user changed his behavior. So in this way, we can actually detect this user behavior change. And we use the sliding window to take the previous day to add more and more data into the training data and retrain the classifier every day. Uh, Here we can see a user before compromise and after compromise. Uh, after com- uh, After the user was compromised, we found this user started sending massive data. You can see this graph is be changed for FTP protocol. So the user started sending massive data, especially using a new protocol, which is totally deviated from this user's normal behavior. So, and actually, the user started downloading private secure files from the system. That was not a normal behavior for him.
Vadim, so if I'm a user who never uses FTP, and one day I would like to download corporate photos, for example, from FTP, will I be blocked?
Um, Actually, it depends on security policies in your organization because rules could be set such way that you will not be blocked at once, but some alert will be triggered, and maybe some secure engineer will have to take a look at it at once, as soon as possible, and he will decide. So a real person will decide what to do with you. So he will check everything, but as I said, this fingerprinting could be also divided more granular. So, for example, if it's just photos, so it's not a secure or sensitive information, maybe not sensitive. It will be anomaly in your behavior, but it will be not a risk behavior. So it will be allowed. So it depends.
Okay, thank you.
Okay, let's take a look at some technologies. Uh, Here you can see several popular technologies used in UEBA. For example, here's Splunk that is used for searching, monitoring, analyzing machine-generated big data. It captures indexes and correlates real-time data in a searchable storage, uh, from which it can generate graphs, dashboards, alerts, reports, and much more. Uh, Also, here we can see Spark. I think many of you know about that. It's an open source distributed computing system, and it provides interface for many programming languages, and it allows program entire clusters with implicit data parallelism and fault tolerance. Also, you can see Python, a very popular programming language, and it's a very famous and popular programming language, especially for AI and machine learning stuff. It has a great collection of machine and deep learning libraries, and maybe provide the best possibilities for prototyping AI solutions. Uh, Cloud technologies. Popular cloud platforms offer scalable, flexible, and powerful tools for security analytics, uh, identity management, and threat detection. For example, AWS. Let's take a look at Amazon Guard Duty. Uh, it's a threat detection service that continuously monitor for malicious activity and unauthorized behavior to protect AWS accounts, workloads, and data stored in S3 buckets. It's instrumental in UBA for its automated analysis of logs and network data. Identity and access management is just a vital part in any infrastructure that resides in cloud. It manages access to AWS services and resources securely. Also, we can see here some services from Google Cloud Platform. It's like Google Cloud Identity. It's a managed identity service that offers identity management, device management, application management, and it integrates with Google Cloud's security. So there are much more services. I don't know all of them, but usually most or all cloud providers have similar services. Okay, so let's take a look at challenges in behavioral analysis. Uh, Actually, it faces numerous challenges that are technical, ethical, and practical in nature. These challenges require sophisticated solutions to effectively analyze behaviors and detect anomalies. One fundamental challenge for behavioral analysis uh, is the need for extensive data. The accuracy of behavioral analysis hinges on the analysis of large and diverse datasets to effectively identify anomalies. To address this, it's crucial to employ big data technologies and data aggregation tools like Hadoop, Spark, and so on. The utilization of platforms like Hadoop and Spark alongside data lakes and advanced analytics tools is vital here, like in any AI big project. Another significant challenge is the complexity of integrating data from various sources to achieve a holistic view of users and entity behavior. By using ETL tools, data integration platforms, and middleware solutions, organizations can effectively consolidate data, which is critical for accurate analysis and precise threat detection. Uh, okay. Distributing anomalies, distinguishing anomalies from risks. Let's take an example. Consider a neighborhood watch program. If someone is walking their dog at midnight, it might be unusual. Yeah, at midnight walking a dog, but not necessarily a threat. However, if someone is trying to open doors, that's a potential risk. AI faces a similar challenge in distinguishing benign anomalies, midnight dog walk, from real threats, the door tester. Using advanced analytics and machine learning is like having a sophisticated neighborhood watch system that learns over time which behaviors are harmless and which could signify risk, thereby reducing false alarms. Lastly, the importance of context is in understanding anomalies cannot be overstated. Also, an example. Imagine you are a teacher in a school. If you see a student running in the hallway during class time. You might consider it's an inappropriate. But if it's during a fire drill, running is expected. This is how context matters in AI for behavioral analysis. Just as a teacher uses knowledge of the situation, class time versus fire drill, to interpret behavior. AI uses contextual information like user roles and locations to determine whether an anomaly, like a sudden spike in data access, is normal activity in one scenario but a potential threat in another. Context-aware security analytics are like the teacher's understanding, helping to distinguish between normal and potentially harmful actions more accurately.
Okay. Thank you for your technical part. It was very interesting. And just to conclude, at the end, I would like to offer you 3 basic tips for successful integrating AI into your solution. So the first one is encrypt your data. The data that you use for training the model. With access to this data, it's much more easy to break your security. The second one is limit access to your AI model. Put it under permission access management. And the third, select a trusted development team that can integrate AI securely and effectively. And for any technical assistance, feel free to contact us at apriorit.com or connect with me directly on LinkedIn. You are welcome. And now it's time for questions. And the first question that we have, let me show it in the chat. Yeah. So, how behavioral analysis differs from SIEM? They're almost the same. Vadim, do you have any details so I can continue?
Yeah.
Okay.
I see. Yeah, actually, yeah, it's a popular question like security information and event management and user and entity behavior analytics. I saw lots of articles on the internet about that. And usually it's not a strict line between them because many CM tools and technologies used in user and entity behavior analysis too. But user if CM solution just uh, analyzes collect it also analyzes collects logs from different sources, but it tries to find and uh, potential threats or intrusion attacks like at spot. So it doesn't like focus on specific entities and users. Imagine uh, if someone have stolen your credentials and logged into the system. Uh, Different monitoring tools will collect logs as usual, and everything will be fine. If he tries to access some private data, same systems will trigger an alert. Maybe access will be blocked, and so on. But if someone tries to mimic your behavior, will just steal. Mm, will not access sensitive files that you've never accessed before. But CM solutions will not find that threats, not find that intrusion. But behavioral analysis contains it collects all the information. It's not focused on uh, on data. It focuses on behavior. So the most important thing in UEB is your profile, your fingerprint. That is your behavior. So uh, it focuses. UEB doesn't know what is bad, what is good. It learns. Same systems knows that, but UEB just looks for your behavior. It can be used not only for cybersecurity, but maybe for other things, but mostly in cybersecurity. It it's focused on your behavior, so it builds your profile and monitors your behavior, and may produce more accurate results, and in some situations it may produce more it may find more threats than just CM systems looking at the logs, finding if you try to access sensitive information or similar, won't find. So even if your behavior slightly change, it will alert us.
Okay, so they are complementary.
Yeah,
They add to each
usually
other.
in practice, yes.
Okay, thank you for your answer. And another question. First of all, thank you for the presentation. For how long it usually takes to train the model from scratch?
Uh, it depends on the type of a model. If you're just prototyping and using some small machine learning models, it will not take too long to just maybe just create a POC. But if you are using a large, for example, convolutional neural network, or uh, let's take CNN, it will take time, but uh, if you have quite good hardware GPU, it's to train a model from scratch for an organization that has, for example, 200 people, and creating uh, a model that uh, just distinguish users and distinguish normal and bad behavior, anomaly behavior. It will take maybe less than an hour. So it's possible to retrain the model every day, and it will not be difficult to scale it to thousands of users. Just
And
adding more
another,
hardware power.
sorry for interruption, another question from Sergey. Does it need to be retrained again? If, for example, we have changed our NTP settings to check the time more often?
Um, actually, yes. So what is normal, what is considered normal, uh, will be changed for your device. So if you don't retrain your solution, it will give you false alarms. You can maybe try to uh, mm, ignore those anomalies about NTP things about NTP protocol, but it's better to retrain the system if new behavior is very different from old one. If it's if it's not a small change, maybe you will not need to retrain it. But actually, yes, any major change will require retraining.
Okay, thank you for your answers. And one question from me. Will AI replace humans in cybersecurity?
Uh, okay. Nowadays, AI is getting more and more intelligence, but uh, AI had the potential to automate certain tasks and improve efficiency, but it's unlikely to replace humans entirely. AI can assist in threat detection and response automation, but human oversight is still essential for decision making.
Okay, thank you very much for your answers. Thank you all for joining us today. We appreciate your participation and active engagement in our webinar. If you have any further questions, you would like to continue the conversation, the discussion, please feel free to reach out. And have a wonderful day and a great ending of the week. Bye.
Thank you. Bye.